Welcome back to the next class of our project management, sir. We are in the process of doing some problems relating to CPM, that is critical path method. Okay. Now look at this. A small project is having 12 activities, sir. What I have to calculate? Network. We have to draw a network. Then earliest timings and latest timings we have to calculate. Look at the problem. This is activity preceded by duration. Activity preceded by for D, B, comma, C, E, A, C, E, H also E, D, F, H, E, I, comma, J and G. Duration 9, 4, 7, 8, 7, 5, 10, 8, 6, 9, 10, 2. Okay, sir, this is my problem. Okay. Now, how to draw a network, sir? Let us recollect the points one after another. A network or a project is always started with independent activity or independent activities. What is meant by independent activity? An activity which is not dependent on anyone. Otherwise, for any activity which has no predecessor is called an independent activity. Look at the information given, sir. First row will represent how many activities we have in the network. Second row will represent what? First row activities are dependent on whom? One more time I am repeating. Second row will tell you what? First row activities are dependent on whom? Third row, look at this, duration. Duration means each activity will take how many days. Then what I have to do? First, simple, draw the network. Second question is critical path identification. And earliest timings and latest timings we have to calculate. So, a network is always started with independent activities. You have to start a network with independent activities. One more time I am repeating, sir. A network you have to start with independent activities. Independent activities are those which are not dependent on anyone. Okay. Now look at this. As far as this network is concerned, A, B, C are three independent activities. A, B, C are three independent activities. This is activity A. This is activity C. Activity B and C where they are merging. Activity B and C where they are merging. Activity D is coming. One more important point what I have to remember is when I am drawing the network, sir, if any activity is having more than one predecessor, then first join these two activities. For example, for activity D, B and C are the predecessors. For activity D, B and C are the predecessors. So first we have to join B and C at one place. When I want to join B and C at one place, sir, B and C are having same initial node. B and C are having same initial node. So network rules will not allow us to join B and C straight away. One more time I am repeating this point. B and C are having same initial node. Okay, clear this point. Next point. As per our network rules, no two activities can have same initial and terminal nodes. No two activities can have same initial and terminal nodes. Therefore, B and C straight away I cannot join. Then how can I join? With the help of a dummy activity. What is a dummy activity, sir? Dummy activities are those which are used to connect two activities, and neither they will take any time nor consume any resources. Okay. So B and C, you join with a dummy activity, sir. B and C, you join with a dummy activity. Now B and C are merged here. Activity D, it is coming. Activity D is coming. This is activity D. As and when activity A is over, you can start activity E. This is activity E. Okay, sir. When E is over, sir. When E is over, you can start E. As and when activity E is over, you can join G, H and J. G, H and J. So I'll do one thing. I'll take activity C in the place of A and A here. Look at this. This is activity A. This is activity B. This is activity C. A and C I am joining here. Activity D will come here. Next, sir. When activity C is over, you can start activity F, because F is dependent on C. As and when activity C is completed, you can go for F. Next. When activity A is completed, you can start activity E. When activity A is completed, you can start activity E. As and when E is completed, sir. As and when E is completed, I can start G, H and J. G, H and J. This way 3 activities I can start simultaneously. Okay. Next. D, F, H. So this is activity G. This is activity H. And this is activity J. Okay. D, F, H we have to join at one place. Activity D, activity H and activity F, I am starting joining at one place. From this, which activity is coming, sir? Activity I is coming. I and G, where they are merging? Activity K is coming. Activity K is coming. As and when activity G is over, we can start activity L. As and when activity G is over, sir, we can start activity L. After this activity L, there is no other activity to connect. Therefore, it is straight away joined at the last node. What network rules are saying, sir? Every network is having only one initial node and one terminal node. So your network is having only one initial node and one terminal node. Fine. No two activities can have same initial and terminal nodes. So there is no two activities here. No two activities are having same initial and terminal nodes. Keeping the rules of network in our mind, we completed the construction of network. Next, after drawing the network is over, sir, you have to give numbers to the nodes, that is circles. We have to give numbers to the circles. How can I give the numbers? Numbering will start from the left hand side and it will go towards right hand side. Numbering will start from the left hand side and we have to move towards right. Once again, one more time, remember what point you have to remember, sir. What point you have to remember? The number given to the head node. The number given to the head node is always greater than the number given to the tail node. One more time I am repeating. The number given to the head node is always greater than the number given to the tail node. So this is the tail node, sir, starting node. This is number 1. Now I am giving for this activity A, this is the head node. Number 2. For this activity C, this is the head node. Number 3. You can give 3 here and 2 here also, no problem. Okay. Next, for this nodes are 2 activities are coming. One dummy activity is merging here and one activity B also merging here. So what number I have to give here? The number what you are giving to this particular node should be greater than the numbers already assigned to these 2 nodes. 1 and 3 are assigned. Therefore, this is node number 4. This is node number 4. Now this is node number 5. This is node number 6. This is 7. This is 8. This is 9. This way 9 nodes we are having. Now sir, let me explain you the construction of this network one more time. A, B, C, D, E, F, G, H, I, J, K, L. These are the activities we are having. First row will always represent the number of activities we are having in a network. Next, second row will tell you what, sir. First row activities are dependent on whom? First row activities are dependent on whom? That is represented in the second row. Now look at the first 3 activities. First 3 activities under these dashes are given. It means they are not at all dependent on anyone. They are not at all dependent on anyone. Therefore, they are called independent activities. Next, activity D, that is starting time of activity D, is dependent on completion time of both B and C. One more time, starting time of activity D is dependent on the completion time of B and C, sir. One point you have to remember. One more point what you have to remember is, for this activity D, B and C are the predecessors. So, any activity is having more than one predecessor. First, these 2 predecessors you have to join at one node. These 2 predecessors you have to join at one node. Okay, next. When A is over, you can start activity E. When C is over, you can start activity F. When activity E is completed, G, H, J. G, H, J. These are the 3 activities you can complete. For activity K, that is starting time of activity K is dependent on the completion time of I and J. And L is dependent on the completion time of G. So question is clear, sir? Very good. Second point, when I am drawing the network, first point what I have to keep in my mind is, you have to start this network, or I have to start this network with independent activities. Okay, generalization. One has to start a network with independent activities. A, B, C are the 3 independent activities. So with these 3 activities, I started the network. Next, for activity D, first I have to join B and C at one place. Okay, sir. B and C are having same initial node. Look at this. B and C are having same initial node. So network rules will not allow you to join these 2 straight away, because no 2 activities in a network can have same initial and terminal nodes. One more time. No 2 activities in a network can have same initial and terminal nodes. Therefore, activity C I am terminating here, and B and C I am joining with a dummy activity. Okay, sir. Next, when C is completed, sir, I started activity F. When A is completed, I started activity E. Because starting time of E is dependent on the completion time of A. As and when activity E is completed, you can start H comma J comma G. 3 activities simultaneously you can start. Okay. Now, F comma D comma H, where they are merging, I is coming. Okay. Otherwise, starting time of I is dependent on the completion time of H comma D comma F. Starting time of I is dependent on D comma F comma H. Therefore, these 3 I joined at this node, and after that activity I is coming. Next, activity I and activity J, where they are merging, activity K is coming. What does it mean actually? Activity K cannot be started. Activity K cannot be started before completion of I and J. Okay, sir. As and when activity G is completed, you can start activity L. Okay, sir. After this activity L, there is no other activity to perform. Therefore, this activity I am joining at the last node. Keeping the rules of network in my mind. Every network is having one initial node and one terminal node. So, keeping this point, these 2 are joined. Next point is calculation of timing, sir. Activity C will take 7 days. Activity B will take 4 days. Activity A will take 9 days. D will take 8 days. E will take 7 days. F will take 5 days. G will take 10 days. I will take 6 days. J will take 9 days. K will take 10 days. L will take 2 days. Okay. Now, let us calculate the earliest timings. Let us calculate the earliest timings. Earliest timing of node 1 is equal to 0. As a rule, you start, sir. Earliest timing of node 1 is equal to 0. How can I calculate the earliest finishing time? Earliest finishing time is equal to earliest starting time plus duration. Earliest finishing time is equal to earliest starting time plus duration. Okay. So, for all these 3 activities, 0 is the starting time, sir. To this starting time, what I have to do? Add the duration to get the completion time. Add the duration to get the completion time. 0 plus 7 is equal to 7. 0 plus 4 is equal to 4. 0 plus 9 is equal to 9. Okay. So on the 7th day, where I am standing, sir? I am standing at node number 3. On the 7th day, I am standing at node number 3. Okay. On the 7th day, what I am doing? Activity F is started. Activity F is started. For activity F, sir, for activity F, what is the starting time? 7. 7th day I can start this one. So, 7 is the starting time of this one. To get the finishing time of this one, what I have to do? Duration should be added. So, 7 plus 5, 12. 7th day I am starting this, and at 12th day I am completing this. It is a dummy activity, sir. Timings are same. On a dummy activity, earliest starting time and earliest finishing time both are same. Now, activity D cannot be started before completion of activity B and C. Activity D cannot be started before the completion of activities B and C. When are you completing the activity B, sir? On the 4th day. When are you completing the activity C, sir? On the 7th day. Therefore, activity D cannot be started before the 7th day. So, earliest time of 4 is equal to 7. Maximum of these two. Look at this one more point. This is a merging node, sir. At the merging node, what I have to do? Maximum of earliest finishing timings. Maximum of earliest finishing time of the activities which are merging here, that should be taken. That is a mathematical way. But what is the logic behind this one? Activity D cannot be started before the completion of these two activities B and C. Okay, sir. Activity B you are completing on the 4th day. Activity C you are completing on the 7th day. Therefore, D cannot be started before 7th day. For activity D, 7 is the starting time. 7 plus 8, 15 is the completion time. Now, sir, through this path, when are you completing activity A? You are completing activity A on the 9th day. Okay. So, earliest time of 2 is equal to 9. I can reach to the node number 2 earliest on the 9th day. As and when activity A is completed, sir, as and when activity A is completed, you can take activity 9. That is activity E I can take. So, for this starting time is equal to 9 and the finishing time is 9 plus 7, 16. Finishing time is 9 plus 7, 16. So, on the 16th day, I am reaching to the number 5. On the 16th day, I am reaching to the node number 5. Clear? Here, activity H will take how many days, sir? 8 days. 16th day, what are you doing, sir? These three are started. Therefore, for these three activities, 16 is the starting time. 16 plus 8, 24. 16 plus 9, 25. 16 plus 10, 26. 16 plus 10, 26. Now look at this, sir. Node number 7 is a merging node. Node number 7 is a merging node. How many activities are merging here? Activity F, activity D and activity H. Out of these three, what is the maximum finishing time? 24. That should be taken. This is a mathematical way. One more time I am explaining. I cannot be started before completion of F, before completion of D and before completion of H. Okay. You are completing activity F on the 12th day. You are completing activity D on the 15th day. Whereas activity H you are completing on the 24th day. So before 24, I cannot be started. Therefore, earliest timing of 7 is 24. Earliest timing of 7 is 24. 24 plus 6, 30. 24 plus 6 is equal to 30. Again, node 8 is a merging node. 25 and 30, maximum is 30. 30 plus 10, 40. Here, sir, to do this, node number 6 you are reaching. To node number 6 you are reaching on 26th day. 26 plus 2, 28. So, earliest time of 9 is equal to 40. So, when am I finishing this, sir? Or when are we finishing this? On the 40th day, we can complete this. This is earliest time. We can complete the project on 40th day. Clear? Wait 1 minute before noting down the solution. Let me do the latest calculations also. Then I'll give you some time, sir. Then you note down. Because my experience, I'm telling, latest time is giving maximum confusion to all the students. Since I'm teaching this paper from 94, Every batch, every student is saying the same thing. Sir, forward calculations are simple, but with backward calculations we are facing problem. So I'll repeat that slowly. Any complicated point I'll repeat 2 or 3 times and I do the calculations slowly. Look at this, sir. Latest timing of 9 is equal to 40. Latest timing means I have to complete this project on the 40th day, sir. Okay. If I want to finish this, if I have to finish this this network on 40th day, if I have to finish this network on the 40th day, sir, these 2 activities are completed on the 40th day, then only you can say project is completed. So for these 2 activities, 40 is the finishing time, sir. 40 is the finishing time. Now, from the finishing time, if I subtract the duration, from the finishing time, if I subtract the duration, I'll get latest time. So, latest starting time is equal to latest finishing time minus duration. Latest starting time is equal to latest finishing time minus duration. So, 40 minus 10 is equal to 30. 40 minus 2 is equal to 38. So, to complete this project on the 40th day, sir, this activity K can be, you have to start on the 30th day and you have to complete it on the 40th day. Here, activity L, you have to start on the 38th day and you have to complete it on 40th day. Look at this, sir. To start activity K on the 30th day, imagine at what time I have to reach node 8, on which day I have to reach on node 8, I must be or I should be at the node 8 on the 30th day. If I reach this node on the 30th day, then only this activity can be started on the 30th day. So latest timing of 8 is 30. 2 activities are merging here. For these 2, 30 is the finishing time. 30 minus 6 is 24. 30 minus 9 is 21. Here, to start the activity L on 38th day, you have to reach to the node 6 on 38th day. One more time. Activity L, you have to start latest by 38th day, sir. To start this on 38th day, you have to reach to the node number 6 on 38th day. So this is 38 minus 10, 28. 38 minus 10, 28. Now, activity I, you have to start the latest by 24th day. Activity I, you have to start the latest by 24th day. It means you have to reach node number 7 on the 24th day. You have to reach node number 7 on the 24th day. Otherwise, it is not possible for us to start this on 24th day. To be here on the 24th day means these 3 activities. These 3 activities I have to complete on the 24th day. So 24 minus 5. 24 minus 5, 19. 24 minus 8, 16. 24 minus 8, 16. Okay, sir. Now look at the calculations at node 8, node 5. At node 5, look at the calculations. Latest, H can be started. You can have to start H on 16th day. J can be started on the 21st day. G can be started on 28th day. One more time. H you have to start on the 16th day. J can be started even on 21st day. G can be started even on 28th day. So to start this activity H on the 16th day, you have to reach node number 5. You have to reach node number 5 on the 16th. So latest timing of 5 is 16. So this is 16 minus 7, 9. 16 minus 7, 9. So latest timing of 2 is 9. So 9 minus 9, 0. This way it is completed, sir. Now, this activity D latest can be started on the 16th day. So, even if I reach node number 4 on the 16th day, no problem, sir. So, latest timing of node 4 is 16. This is a dummy activity, sir. 16, 16. Here it is 16 minus 4, 12. 16 minus 4, 12. Now, 16 and 19. Minimum is 16. So, latest timing of 3 is 16. 16 minus 7, 9. Now, sir, 0, 12, 9. Minimum is equal to 0. Why minimum I have taken, sir? Why minimum I have taken here? Look at this. Activity A, you have to start latest on the 0th day. Activity B, latest you can start on the 12th. Latest, activity C, latest you can start on the 9th. Minimum of these three is 0 only. So if you don't start this one on the 0th day, you cannot start this one. Therefore, you have to reach to this particular node at the 0th day. Okay, minimum. Otherwise, at the bursting node, minimum of latest timing should be taken. Clear, sir? Now I'll give you 1 minute time or 2 minutes time for you to note down. Understand first. Any doubt I'll tell you. See, most of these problems are solved examples in our study material. Look at the 2012 version. That is 12 syllabus. First edition, first and second version, some pages are deleted, sir. So I'm taking these problems from final. It was in the final. So I'm doing the problems from final scanner. That is suggest answers also. Note down this. Okay, sir. Let's go to the next problem. Look at the next question, sir. This is activity. This is a duration. Activity 1, 2, 2, 3, 2, 4, 3, 6, 4, 5, 5, 7, 6, 7, 7, 8, 7, 8. Duration 4, 12, 18, 10, 12, 10, 20, 16. Duration is in days, sir. Draw the network and identify the critical path. Okay. Now look at this activity 1, 2. This is activity 1, 2. 2, 3, 2, 4. 2, 3, 2, 4. 3, 6. This is 4, 5. 3, 6. 4, 5 over 5, 7, 6, 7. 5, 7, 6, 7, 7, 8. Simple network, sir. Now, activity 1, 2 will take 4 days. 2, 3 will take 12 days. 2, 4 will take 18 days. 3, 6 will take 10 days. 4, 5 will take 12 days. 5, 7 will take 10 days. 6, 7 will take 20 days. 7, 8 is taking 16 days. Okay, this is given. Let's calculate the earliest timings. Earliest timing of node 1 is 0. 0, 4. 0th day I am starting and 4th day I am completing. So earliest time of 2 is equal to 4. On the 4th day I am reaching to the node number 2. So earliest timing of 2 is 4. 4th day what I am doing, sir? 2, 4 and 2, 3. 2 activities. 2, 4 and 2, 3. 2 activities are simultaneously started by me. This is 4 plus 12, 16. 4 plus 18, 22. Earliest timing of 4 is 22. Earliest timing of 4 is 22. So 22, 34. 22 plus 12, 34. Earliest timing of 3 is 16. 16 plus 10, 26. 26. 26 plus 20, 46. Earliest timing of 5 is 34. 34, 10, 44. 44 and 46 maximum is 46. Logic already I explained in the previous question. So I am doing this without that logic. That is without repeating that logic one more time. 46. Simply you remember, sir, at the merging node, maximum of earliest timings of the activities which are merging here you have to take. 46, 46, 62. 6 plus 6, 12. 4 plus 1, 5 plus 1, 6. 66. So earliest time of 8 is equal to 62. Earliest time of 8 is equal to 62. Okay. Let's go latest timings. Latest timing of 8 is 62. You have to complete the project on the 62nd day. 62nd minus 16, 46. Look at this, sir. 62nd is the completion time of this one. From this I have to subtract the duration. 62 minus 16 is 46. So to start this activity on the 46 means I have to reach to this particular node 7 on the 46th day. So latest timing of 7 is 46. If I have to be at node number 7, if I have to be at node number 7, sir, activities 5, 7 and 6, 7 I have to complete on 46th day. So this is 46 minus 20, 46 minus 10, 36, 46 minus 10, 36. To start this on the 36 means I have to be here at node number 5 on 36th day. 36 minus 12, 24. To start activity 6, 7 on the 20th day means, sir, I have to reach to the node number 6 on the 20th day. So latest timing of 6 is 20. So 20 comma 10, 10. 20 minus 10, 10. To start this activity on the 10th day, you have to reach to this particular node on the 10th day. This is somewhere I committed mistake, sir. 10 minus 12 I am getting negative value. 46. 46 minus 20. 26. This is 26. 26 minus 10, 16. So this is 16. 16 minus 12, this is 4. 16 minus 12, this is 4. This way, activity 4, 5, I have to start latest by 24. It means I have to reach to the node number 4 on the 24th day. 24. So 24 minus 18, 6. Now sir, 4 and 6 minimum. Latest timing of 2 is 4. Look at the logic here. Latest you have to start 2, 3 on the 4th day. Latest you can start 2, 4 even on the 6th day. To start 2, 3 on the 4th day, sir, you have to reach to the node number 2 on the 4th day. Otherwise you cannot start 2, 3 on the 4th day. Okay. So this is equal to 4 minus 4, 0. Latest timing of 1 is 0. This way, these two timings will coincide with each other, sir. These two timings coincide with each other. Clear? Now, after drawing the network, how can I identify which one is critical path? Okay, sir, how can I identify which one is critical path? Look at the network. There are some activities on this network whose earliest and latest timings are same. Look at this network. There are some activities on which earliest and latest timings are same. Look at this. For this 1, 2, earliest and latest timings are same. For 2, 3, earliest and latest timings are same. For 3, 6, earliest and latest timings are same. And for 6, 7, earliest and latest timings are same. And for 7, 8, earliest and latest timings are same. So these activities are called critical path activities. These activities are called critical path activities, and this path is called critical path. Okay, again, maybe for the first question you may not get any doubt, sir, but once you enter into the subject, after doing a problem or 2 or 3 problems, doubts will start coming into your mind. Why should I calculate critical path? What is the importance of critical path? What will happen if the completion time of this critical path is delayed by 1 day? Okay, sir. Look at this. The path which is having longest duration is called critical path. Clear, sir? The path which is having longest duration is called critical path. Second point, for critical path activities, earliest timings and latest timings are coinciding with each other. It means you cannot delay the starting time of these activities as well as the finishing time of these activities. What will happen if I delay the starting time or finishing time of any of these activities by 1 day? Look at this, sir. If it is delayed by 1 day, this activity can also be delayed by 1 day. So all the succeeding activities are delayed. Fine. So the project completion time is also delayed by the same number of days. So as a contractor, once your engineer has given the drawing of this network and identified what are the critical path activities, what instructions you are taking, sir? What instructions you are giving? Complete the critical path first. Once critical path is completed, then we are concentrating on the non-critical path activities. Okay. This is the importance of critical path. So, completion time of critical path is delayed by even 1 day. The project completion time is also delayed by the same number of days. No float is available for critical path activities. Okay, sir? Now, take up this. Let's see one more question, sir. Look at the next question. Activity preceded by duration. Preceded duration. This is A, B, C, D, E, F, G, H, I and J. Preceded by dash dash A comma B. This is B, A, C, E comma F, D comma F, G comma H, I. Duration is 384, 217, 568, 9. Okay, sir. Now, first we have to draw the network, identify the critical path. After that we will calculate floats also. Okay, what is float? How many types of floats are there? That I will tell you, sir. Look at this. Activity A and B are independent activities. Activity A and B are independent activities. As and when activity A is over, you can start activity E. As and when activity B is over, sir, you can start activity D. As and when activity B is over, you can start activity D. Clear? But for activity C, A and B are both predecessors. For activity C, A and B are the predecessors. Sir, for A and B I have same initial node. For A and B I have initial node. So network rules will not allow us to join these two. What I am doing? From this B, one dummy activity is taken. Again from this one dummy activity is taken. And C is coming. C is coming. Next. A, B, C, D, E over F. Once activity E is completed, you can go for F, sir. You can go for F. E and F, where they are merging. Activity G is coming. E and F, where they are merging. Activity G is coming. Activity D and F, where they are merging. Activity D and F, where they are merging. Activity D and F, where they are merging. H is coming. H is coming and it is G. Now sir, G and H, where they are merging, I is coming. And from this I, activity J is coming. Okay. This way a project is completed. Network is completed, sir. Numbers we have to give 1, 2, 3. Once again, remember the number given to the head node is always greater than the number given to the tail node. One more time, sir. The number given to the head node is greater than the number given to the tail node. So this is 4, this is 5, this is 6, 7, 8, 9, 10, 11. Now activity A will take 3 days. Activity B will take 8 days. C will take 4 days. C will take 4 days. D will take 2 days. E will take 1 day. F will take 7 days. G will take 5 days. H will take 6 days. I will take 8 days. J will take 9 days. Now sir, earliest timing of 1 is equal to 0 as and when the project is allotted to you. As and when the project is allotted to you, you can start this network. Next, 0th time you are starting this, on the 8th day you are completing, because activity B will take 8 days. Clear? 0th day you are starting and 3rd day you are completing, because activity A will take 3 days. So on the 3rd day you are reaching. On the 3rd day you are at the node number 3, and on the 8th day, you are at the node number 2. 8, 8. This is 3, 3. Earliest starting time, earliest finishing time. Earliest starting time, earliest finishing time. So it is a merging node, sir. Maximum of 3, 8 you have to take. Maximum is 8. Earliest timing of 4 is 8. 8 plus 4, 12. 8 plus 4, 12. So, earliest timing of 5 is 12. Earliest timing of 5 is 12. 12 plus 7 is 19. This is 2 plus 8 is 10. Here 3 plus 1 is 4. It is earliest timing of 6 is equal to 19. Dummy activities are 19, 19. 19, 19. 7 is the merging node. At this merging node, maximum of these two timings 10, 19. Earliest timing of 7 is 19. 19 plus 6 is 25. Earliest time of 8 is equal to, this is also merging node, sir. 4 and 19, maximum is 19. So this is equal to 19 plus 5, 24. Okay. Node 9 is again a merging node, sir. Node 9 is a merging node. 25 and 24, maximum is 24, 5. Earliest timing of 9 is 25. 25 plus 8, 33. Earliest timing of 10 is 33. 33 plus 9, 42. Earliest timing of 11 is 42. When shall we complete the network? On the 42nd day, earliest we can complete the network. Every time, sir, everyone is feeling very comfortable with earliest timings. The problem will come with only latest timings. Okay, one more time. Latest timing of 11 is equal to 42. Sir, to complete the network on the 42nd day, this last activity should be completed on the 42nd day. How many days it will take? 9 days. So, latest you have to start this on the 33rd day. To start this 33rd day, I have to reach node number 10 on 33rd day, on day number 33. So, day number 33, if I have to be here means, its preceding activity should be completed on day number 33. 33 minus 8 means 25. To start this activity on 25th day, I have to be at node number 7 on day 25. So latest timing of 9 is 25. 25 minus 5, 20. 25 minus 6, 19. Okay, sir. To start this activity G on the 20th day, I have to reach. Okay, I am coming this way also. Let me come first. This is 19. Latest, sorry. Latest timing of 7 is 19. 19, 19. Latest timing of 8 is 20. So this is 20, 20. Sir, this activity you have to start on the 19th day, whereas this activity you can start even on the 20th day. So to start this on the 19th day, you have to reach this node number 6 on the 19th day. One more time. Activity H you have to start on the 19th day, whereas activity G you have to start on the 20th day. Clear? So to start activity H on the 19th day, I have to reach to the node number 6 on 19th day. Latest timing of 6 is 19. Okay, sir. 19 minus 7 is 12. 19 minus 7 is 12. Latest timing of 5 is equal to 12. 12 4 means 8. This way it is 20. Minus 1 means 19. Latest timing of 4 is 8. It is a dummy activity, sir. 8 8. 8 8. This is latest finishing, latest starting. This way it is 19 to 17. 8 and 17, minimum is equal to 8. 8 minus 8 is 0. Okay. Latest timings and earliest timings are calculated. By the time when you reach to the node number 1, sir, earliest time and latest time coincide with each other. Earliest time and the latest time will coincide. 8 and 19 means minimum is equal to 8. This is 8, 3 means 5. And here 0 and 5 means 0. This way construction of network is over. Now identify the critical path. How can I identify the critical path, sir? Looking at the network. Have a close look on the network. There are some activities for which earliest and latest timings are same. Look at this activity B. Look at this activity B. For this earliest and latest time same. And this dummy also this way route. Next activity C. Earliest and latest time same. For activity F. Earliest time, latest time same. Again for H. Earliest time and latest timing same. Earliest and latest timing same. Earliest and latest timing same. This way you have to identify the critical path. Now sir, I am in the construction business. Therefore, when my engineer has submitted this one, what advice he will give you or what information we will get? Managerial Information System, MIS. We have to concentrate first on the critical path activities. Even though you are a contractor, your engineer only will do these tasks. Work is completed under the supervision of engineer only, but every time, or that is at the end of every week, he will give you the report. So, what information you are getting from your engineer, sir? Which activities you have to complete first under any circumstances. Now comes critical path non-critical path activities. Non-critical path activities are those which are not on the critical path. Okay. That part, calculation of float, I will take up in the next problem, sir. I will reduce the length of this network. So that I will prepare a table for that also. Okay. Before that, you take up the solution of this.